Good day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, and click on the notification button to have more of my video. Today, we are having a topic in mathematics, and that topic is calculus. And then, under this calculus, I will introduce the concept of differentiation and integration. Thank you. Now, when we talk about calculus, calculus is divided into two parts. So the first part of it is called differentiation. The first part of it is called differentiation. And the second part of it is called integration. So the essence of this particular class is to introduce us to the concept of calculus, which is divided into two parts: differentiation and integration. Now, I want to start from the point view of what is called average rate. Let's call it average rate. So there are two sets of rates. Take note of this. There are two sets of rates. We have two sets of rates, and then we have the first set, which is called average rate. Average rates. Then we have what is called instantaneous rate. This can also be referred to as a rate of change. Let's say average rate of change. Average rate of change. And we can call this one instantaneous rate of change. So, what do you mean by the average rate of change? Let's start with the average rate of change. That's the first thing we need to start with. Average rate of change. Let's consider this particular Cartesian coordinate system. Y to be taken as function of variable x. So the dependent variable, which is called y, is on the vertical axis, and the independent variable, which is called x, is always on the horizontal axis. The point of intersection of these two axes is called the point of origin. Now, let's say I have the graph of this y with respect to x. After plotting the graph here, I have the first point. Call it point P1. P1 has a coordinate s1, y1. And let's say we have point P2. P2 has a coordinate of x2, y2. What do I mean by coordinates? Is the value along the x-axis and along the y-axis that describe the location of these points. Like for instance, if I start along the x-axis across this place, I will move in this direction, and the value of my movement will be x1. And before I get to this P1, the value of my movement vertically will be y1. So in order to summarize this movement, I have what is called s1, y1. They are called coordinates. The first one here that we have here is called abscissa. It is named abscissa. Abscissa. The second one that we have here is called ordinates. Ordinates. So now, if you want to find the slope of this graph, the slope measures the orientation of this particular graph with respect to the horizontal. Let's say the orientation is at angle theta. We can assume that this particular line is on the horizontal axis. So when you now shift it to this point, we have a movement, angular movement, which is this theta. So we want to measure the relative position of this line with the horizontal. So the slope measures the relative position of a line with the horizontal. So how do we do that? we can find what is called tan theta. So slope is actually written as letter M, and the same thing as what is called tan theta. Now from trigonometry, tan theta is opposite over adjacent, and the opposite here will be, this particular y2 will be here, and the x2 will be somewhere here. So the opposite is this particular height of this triangle that I have with respect to this angle theta, and which is different between y2. The y2 is measured from here up to this place along the vertical axis, and the value is y2 down, and the x2 is measured from here, and s1, so y1 is measured from here to this place, and can also be written as this place now from here to here. So the height of this triangle that you see here will be the difference along the vertical axis. That is y2 minus y1. So this place is y1. So it's going to be y2 minus y1. That's the height of this triangle. You have y2 minus y1. When you look at the base of this triangle, we measure x2 from the origin to this place. We measure x1 from the origin to this place. So the difference between this measurement here will constitute the base of this right angle triangle. So the base will be x2 minus x1. So if I bring this diagram down here, I have my theta, then I have this changing along the y-axis, and I have changing along the x-axis. Change along the y-axis is y2 minus y1. The change along the x-axis is x2 minus x1. So the definition of a slope is tan theta opposite over adjacent, which is change in y-axis all over change in along the x-axis. So now the change along the y-axis is y2 minus y1, and along the x-axis is x2 minus x1. So that means this particular slope now is the average, it's called the average rate of change. So the average rate of change now is simply y2 minus y1 divided by x2 minus x1, and it's written in summary as change in y divided by change in x. So that is the average rate of change. Now when we want to consider instantaneous rate of change, we have, in this case, we consider, instead of a straight line graph, we are going to consider a curve. Let's say we plot the graph of the independent variable x against the dependent variable y, which is function of x. Let's say after plotting this graph, I have something like this. Now, if I take this point P1, which is x1, y1, and I take point P2, which is x2, y2 here. Now, if I want to find the slope between P1 and P2, in that case, we are finding what is called the average rate of change. The slope of this graph will be average rate of change, which is what we just did here. So in a nutshell, and if you now take a point at the mid location between point P1 and P2, call that point P1. Just call that point ordinary P. Now, I want to let us take note of something. You know that the slope is along a straight line. So the slope between point P1 and P2 is what we just did the other time. So the slope, that is the average rate of change. Average rate of change. This occurs between point P1 and P2, and is given as a change in y over change in x. But as point P, as any of this particular point P2, as point P2 move towards P, the average rate of change that I have here, delta y over delta x, as you know, as this point P2 is moving towards this point P1, the difference between this particular difference, delta x, between these 2 points will be reducing to a limit called the x, and at this point it's also moving, the value of y2 will also be decreasing. So at this particular point, which is tangential to the curve, original curve of y is equal to f of x, what I'm trying to say is this. Let's say I have the point P here, then I have the point P1 here, I have point P2 here. You know that this particular line, along this particular line, we calculate what is called a slope, and that slope is called the average. But as point P2 moves towards point P1, this particular line will become tangential to the curve f of x. So in a nutshell, like I said, as P2 moves towards this point P, this particular line here will become a tangent. This line here is more or less a chord. So this particular chord now become a tangent. So the slope of this point here, of this line here, is the limit of the average rate of change, delta y, delta x, and that limit takes place as delta x tends towards 0, is given as dy over dx. This particular dy over dx is called derivative. Because it is called derivative because we derive it from function f of x. We derive this particular dy dx from function f of x. So this particular derivative has another name. Is called instantaneous rate of change. It also has a name, and the other name is called differential coefficient. So you can come across different names of this dy dx. So this is the relationship between the average rate of change and instantaneous rate of change. Now this brings us down to the difference between integration and differentiation. Now let me now introduce these two things to us. Let's say I want to differentiate between differentiation and integration. Differentiation and integration. Let's start with differentiation first. Number one, differentiation. Differentiation first. So let's start with differentiation first. Now, differentiation we normally write it as we normally call it a process of finding the derivative. Finding derivative of function y is equal to f of x. So how do we find the derivative? Let's say function y is equal to f of x is given as as raised to power n. Then the derivative of this function, we normally donate it with y prime, which is same thing as just put prime here, f prime of x. So, and it is called dy dx. Now when you are finding dy dx given this particular function now, what we normally do is to multiply the power with whatever coefficient that you have here, then you subtract 1 here. In my other video, I'm going to describe why this particular process is done this way. So when you are finding the derivative, or when you are doing the process of differentiation, use the power to multiply. So we have n times a, then you subtract 1 from this n. So this is it now. How to find the derivative of a function. Example, let me say I have y is equal to 3x squared. Then y prime is also known as dy dx. So use this power to multiply. That is 2 times 3. Then you subtract 1 from here. So 2 times 3 will give you 6. X raised to power 2 minus 1, 1. So the y prime, which is same as the y dx, is given as this. Now, if you want to differentiate a constant differentiation, let's say we have a constant function. Let's say this particular y is actually a constant c. We want to find y prime. What is y prime? Now, to be able to do that, you are given function f of x, which is y, to be c. We want to find y prime. This is what you are going to do. We can rewrite y as cy raised to power 0. You know, in mathematics, anything raised to power 0 will give you 1. So this particular expression that I have here and this expression, they are the same thing. Now, to find the y dx now, you write the y dx. You use this power to multiply. 0 times c y raised to power 0 minus 1, using this particular expression here. So 0 times anything is 0. So you have the y dx is equal to 0. So that means, in conclusion, derivative or differentiation of a constant in calculus is usually 0. Now, let me give an example of this particular differentiation of a constant. Let's say we have a function y is equal to minus 5. So to find the derivative y prime simply means the y dx, and it's same thing as f prime of x. Now, this particular minus 5 that we have, this y is equal to minus 5. From this y is equal to minus 5, we can rewrite this minus 5 as minus 5y raised to power 0. Or we can simply just say the y dx is equal to 0 times everything here. 0 times minus 5 y raised to power 0 minus 1, which is equal to 0. So differentiation of a constant is 0. So that's that. And then when we are dealing with differentiation application in mathematics, we normally find application of differentiation. We normally use it to find instantaneous A velocity, and then B, we also use it to find instantaneous acceleration in physics. Let me give an example, then I will go down to the other aspects of calculus, which is integration. So here, for instance, example, let's say the distance covered by a particle, the displacement of a particle with respect to time, t, is given by displacement x is equal to t squared minus t plus 4. Find its instantaneous A velocity, B acceleration at time t is equal to 3 seconds. Now, we are told that our displacement is this, and the time taken to cover that particular displacement is given as function t squared minus t plus 4. what this one actually means that you have here is actually means that x is equal to function of time t in this format. So to solve this problem now, we are given displacement x is equal to t square minus t then plus 4. The velocity, like I said, is internal rate of change of displacement with respect to time. So we now use the idea of derivative I taught us the other time. We use this power to multiply it, subtract 1. We are going to have 2t minus, use this power here 1 to multiply this coefficient here. Then you subtract 1, so everything here will be 1. And differentiation of a constant will give you 0, that is plus 0. So that means our velocity now is 2t minus 1 meter per second. And as time t is equal to 3, so velocity as time t is equal to 3 seconds. Simply means you substitute this 3 here. So it means 2 times 3 minus 1. 2 times 3 is 6 minus 1, which is 5 meter per second. Now, according to physics, acceleration is given as change in velocity, the international rate of change in velocity with respect to international rate of change in time. Now, the velocity that we have here is 2t minus 1. So we can write it as the 2t minus 1 dt. So that means we need to redifferentiate the velocity that we obtain again. When we differentiate this, you use 1, this power to multiply. So you have 2. Differentiation of a constant will give you 0. So that means acceleration now is 2 meter per second squared. So this is one important area where we use application of differentiation. We normally use it for rate of change. Our rate of change may be increasing or decreasing rate of change. So when we talk about rate of change, increasing simply means, in a practical illustration, means growing or growth. That is growing rate of change. Then your rate of change can be decreasing rate of change. So we normally say decaying in physics. Like for instance, if you are pouring water inside this container, the height of the water will be going up. So we have what is called increasing rate of change. But if you are fetching water from the tank here, if water you are fetching, the height of this water will be going down. That is decreasing or decaying. So so far, and then this rate of change can be rate of change of population in agriculture. This particular application of differentiation is used in engineering, in science, and it's also used in social investigations. I believe that you must have learned one or two things on the concept of differentiation. In my next video, I'm going to take us through the concept of integration. Have a nice day. Bye bye. Thank you.